This is 11-1-3. We're going to add and subtract rational expressions. And so today's objective, we're going to add rational expressions and subtract rational expressions. So let's do some quick review. If you guys remember, if we're going to add or subtract fractions, we have to make sure that the denominators are the same. And so be able to add these together. 8 plus negative 2. That's technically on top. And then because we're talking about it cut into ninths, whatever that denominator is, it stays the same. So the 8 plus negative 2, that's just 6. 6 over 9, and we'd reduce that down into 2/3. Now, if there's variables involved, what's going to happen here, right? Our denominators are the same, so it's still a 3 on the denominator, but we're just going to add the tops, x plus 2. You can't reduce that further. We're done. So just know that we can add or subtract with variables involved, and there's no crazy trick to it. Now, we know how to add or subtract when we have different denominators, right? You've learned, hey, what we need to do is you need to find the common denominator. And by finding the common denominator, it's like, well, what would make these the same? And so you're probably thinking, oh, well, I can make them into 20. And so then this would need a 2 over 2. And so that would become 1 times 2 over 20 plus 2 over 20. And so 1 times 2 is this 2. So 2 plus 2 gives me 4 over 20. And ... you'd be able to simplify it from there. But there's one important thing that's missing from this scenario here. And so we're going to re-examine that. And what I'm going to do is I'm going to completely factor this. So this will be 1 over 2 times 5. And this is going to be plus 2 over 2 times 2 times 5. Now, when we use the phrase, we're finding the common denominator, what we're actually trying to do is we're trying to find the common factors down in the denominator. We want to make sure that all of the factors are the same. And so when we're looking at this, 2 and 5, 2, 2, and 5, we have to ask ourselves what's missing. What needs to be completed to make all those factors in the denominator the same? And so in this instance, this side needs an extra 2. Now they're both the same. Well, I can't just magically add a 2 out of nowhere, and so that's why I have to do it to the top as well, because 2 over 2 is 1. I can multiply anything by 1. And so that is what's going on behind the scenes as to why I need to multiply and make the denominators the same. And so making the denominators the same is making all the factors in the denominator the same. That's all we're doing. The factors need to be the same. So let's kind of turn up the heat a little bit. First example, we need to simplify these. So I just need to check. Denominators, are they the same? They sure are. So I can add these together. 2x plus 7 over 2x squared plus x minus 21. Now, just because we just didn't add these together doesn't mean that we can't simplify it. So if we go back to this previous example here, I added things together and I was able to simplify it. I added things together and I was able to simplify it. So I added things together. I might have to be able to simplify this. So examining this, well, that's a plus in between the 2x and 7, so I can't, they're not factors, and there's nothing the same top and bottom, so I have to try and factor this. A times C, B, so what factors of 42 add to 1? And that's going to be 6 and 7, and so it'll be a negative 6 and a positive 7. And so I'll just do it off to the side. 2x squared minus 6x plus 7x minus 21. So I can use these numbers to break apart that x. And so now factor by grouping, factor out 2x. So you get x minus 3. And then what's in common here is a 7. So you get x minus 3. So you rewrite what's the same, which is going to be x minus 3. And then whatever is the same, 2x, positive 7, goes in the other parentheses. So now I have 2x plus 7 on top. And I have this x minus 3. And this 2x plus 7. Those cancel out. And so I get 1 over x minus 3. For this one right here, we have to check, are the denominators the same? They are. So now I can do the subtraction. 5x minus 15. So 5x minus 15. And on the bottom, x squared minus 2x minus 3. Maybe something's going to reduce. I don't know. The way that I'm going to have to check is by factoring. So on top, I could factor out a 5. On the bottom, a times c, factors that add to b, 3 and 1. So that's going to be x minus 3 and x plus 1. And so those x minus 3's cancel out. And so I'm going to get 5 over x plus 1. So now we have an example here in which, if we notice, our denominators are not the same. And so now we have to go all the way back to this slide here, where I said when we have to find the common denominator, what we're looking for is to make sure all the factors are the same in the denominator. So let's look at the factors. Well, I have a factor of 3x plus 1. I have that factor here, and I have that factor here. So they both have that. But this one has an x minus 5. The other side doesn't. So they both have to have the same factor. So x minus 5. Now they both are the same, but I can't just put that x minus 5 out of nowhere. And so it's going to go on top as well. So now I have x minus 5 times x plus 2x squared minus 2 all over, we just keep the denominator. So now those x's distribute, and so I get x squared minus 5x plus 2x squared minus 2, and that's going to be all over x minus 5 and 3x plus 1. So simplifying the numerator, the x squared and the 2x squared will combine together. So I get 3x squared minus 5x minus 2. And so now, how does that factor? A times c, factors of that add to b. So is that going to be negative 6 and positive 1? So that should be that. And then on the bottom, I still have that. And so then those will cancel out. And so your answer is x minus 2 over x minus 5. Last one. Same idea. I need the denominators to be the same thing. So they both have an x plus 3. They do not both have an x minus 3. This side does, this side doesn't, so I'm going to make them the same. Well, I can't just put that out of nowhere. I also have to do it to the top. So now rewriting that, I have 9 minus 3x plus 2x times x minus 3 all over x plus 3 times x minus 3. Now we got to simplify this. So the 2x's will distribute. And so now kind of reorganizing this a little bit. So I'm going to have 2x squared. The 3x and the minus 6x will turn into minus 9x, and then I have plus 9. So let's see how this is going to factor. So a times c, 18. Factors of that are going to add to b. So I have negative 3 and negative 6. And so that's going to be 2x minus 3 and x minus 3. Just saving some time. And in the denominator, I still have x plus 3 and x minus 3. Those cancel out. And so that's going to be my answer. So what did we learn today in closing? We learned how to add and subtract rational fractions or rational expressions, including variables, so rational algebraic expressions. Just remember, when we add or subtract these fractions, we have to make sure that the denominators are the same. And one of the ways to analyze if they're the same, we want to make sure that all the factors in the denominators are the same. So just quickly going back, notice here, x plus 3, x minus 3, x plus 3, x minus 3. And here, x minus 5, x plus 3, x minus 5, and x plus 3. They have to have the same factors. And once they have the same factors, we know that the denominators are the same. This does conclude our lesson. If you have any other questions, please leave them in the comments.